The future is crafted from imagination. A texture your fingertips are yearning to touch. A color your eyes are bursting to see. We've not only envisioned a sustainable future for 17 years, we've been practicing it along the way. We are determined to lead a future with unprecedented confidence. To build a safe, intelligent, and efficient platform. And to grow an ecosystem that lives with nature. Green energy powers the future.
Hello, everyone. So this is Onat from AUTEL. Welcome to our second webinar after last week. I want to thank you all again for joining our webinar. So I will be your presenter again, and I am sure that we will have a good time together like our first webinar session. If you have any questions during webinar, please don't hesitate to ask in the question and answer section below. My colleagues will gladly answer your questions. So we said that we need to adapt the future, right? Electric vehicle conversion or transformation is real, and we need to adapt. But not as a professional, as an end user, still we have some doubts. So let's imagine you bought your electric vehicle, or before buying it, you are not sure which kind of charger you need, right? So today we will figure out together the answer for that question. So please, again, be relaxed, sit back comfortably, get your coffee, and let's get started. So what are our topics today? So as you can see in the screen, we will see again a little reminder for electric knowledge, and again a little reminder for charging of different vehicle types. And after, we will see what is AC and DC charging. And after, we will see the mode specification for chargings. After that, we will see charging specifications for some electric vehicles. We will see some examples for electric vehicles. And after, we will see the purposes of usage for electric vehicle charger. And lastly, we will see a little bit about our AUTEL Maxi Charger series. Okay, so if you remember from our last webinar, yes, we talked about electricity a little bit, but I want to do a reminder because we will add on to this information, okay? Yes, we said electricity is the phenomenon, our energy to move the electric vehicle, right? We need electric voltage, the difference of electric potential. The voltage unit is called volt. And of course, we have natural electric current created by the potential difference. Unit is A, ampere. So we also talked about the relation between, right? These guys explained us about the relation. The potential difference, the yellow guy, creates the current, the green guy. But on the road, the red guy, resistance of the cable or like other equipment, will oppose it, right? Let's see their relation in detail. The relation between voltage, current, and resistance, that is, voltage is equal to current times resistance. All right, as can be seen in the relation, they are dependent on each other, right? When you increase the voltage, current should increase. So when you think the resistance is same, so when the voltage is increasing, the current should increase. Also vice versa. So if current is increasing, voltage is increasing also. Okay, so we have another important relation for today's topic. That is power. You all actually know about what is power. as a horsepower, right? Horsepower is a power unit. Also, we will see in the relation between them, but we will talk mainly about watt or kilowatt today, because we need to understand what is like 7.4 kilowatt AC charger, or what is 22 kilowatt AC charger, or what is 120 kilowatt DC charger, okay? In the relation, you see that power is equal to current times voltage, which means if you increase the current, then power will increase, or if you increase the voltage, then power will increase again. So let's see the relation between horsepower and kilowatts, because they are both power terms and their relation is like this. 1 kilowatt is equal to 1.34 horsepower. So for example, you have 100 kilowatt powered electric vehicle. So you can say this is 134 horsepower car. For electric vehicles in their technical specs, always kilowatts is given, but you can easily convert it to horsepower, okay? So don't worry. Both terms are power terms. So let's come to our topic. What is electric vehicle charger? So EV chargers are our equipments that connects to the electric vehicle to source of electricity to recharge our high voltage batteries in our electric vehicles. They are also called electric vehicle supply equipment, which is EVSE. So we have AC chargers and DC chargers. Let's see the differences. First, AC charging. Yes, we mentioned the way of AC charging in our last webinar. So just in case, let's see it again. When you connect your car to AC charging, the electric power, as you know, goes through our onboard charger, which is our charger module. Then after, it goes to power module, DC-DC converter, and after, high voltage battery. Also see the DC charging. So from the grid, we are taking the electricity, and these red stacks is our DC charger, okay? If you remember, we mentioned a little bit that the high voltage direct current, HVDC, in the screen, is directly going to the battery. We are bypassing our onboard charge or charging module. As you can see, it goes to the BMS. BMS is battery management system. It is responsible to manage the charging the modules at that time. If you connect a diagnostic tablet to your car, you can find all the information regarding battery modules and cells. These informations actually comes from the BMS. It is very important to know about BMS, okay? So yes, we said our DC charger, the red rectangles here. Maybe you can ask why there are rectangle stacks. Because in DC chargers, we have multiple power modules that determine the power of the charger, okay? And we will come to that, don't worry. But as you can see, DC charging systems are more complicated compared to AC chargers. So we have also the modes. Let's see the charging modes, okay? In the market, there are kind of different modes. You can maybe hear it as a level 1, level 2, level 3. But we will see as a mode 1, mode 2, mode 3, and mode 4. We will go one by one. Mode 1, it is AC charging directly with a cable. But this cable has no control protection protocol. So it is not recommended to use, okay? And we have mode 2. It is AC charging again, but now we have control and protection, but limited safety features. It will be slow again due to the low output power, okay? Also, it is not very recommended. And mode 3, is also AC charging, but we have now a dedicated wall box with control electronics built in. Now the power output is increased a lot because we can charge our car with three-phase electricity. Three-phase electricity power is a common type which uses polyphase system. We will not go in detail to blow your minds. It is actually the most common method used by electrical grids worldwide to transfer power in every country, okay? So we will see the calculations together, so don't worry. So remember that mode 1 and mode 2 is slow because they are single-phase charging systems and they are not recommended actually. We saw the mode 3. And lastly, we have mode 4. It is DC charging, which is very fast. It is generally using for public charging and the output power is of course very high. So mode 3 and mode 4 are most recommended charging methods in terms of safety and efficiency. Yeah. Let's see the connector types once more. These are the connector types are all around the world. Our region, we talked about it last week. IMEA region mostly using Mennekes Type 2 for AC charging and CCS2 connector for DC charging. There may be some imported cars, we talked about it, like with different connector types compared to your country's regulations, but as we said, don't worry, day by day, these numbers are decreasing due to the regulations. So, before giving examples on electric vehicles, so let's remind the vehicle types again. If you remember these three types, can you tell me which of them can be charged with AC? I want to ask the question. Please answer the question in the screen. Let me share this question with you. Okay, it's a little bit tricky question because I say like charge with AC. Okay, answers are coming. Okay. Many of you answered already, and whoa, it is distributed. It's kind of distributed. All right, so let's see the results. I think many of you already answered the question. All right, let's see. It's very distributed. Actually, the answer is all. On the screen, as you can see on the screen, plug-in hybrid, extended range hybrid, and full electric can be charged with AC charging. So let me continue. Maybe you remember from last week, yes, these are all high voltage. We can charge them with AC, but for plug-in and extended range, it is optional. If you want, you don't need to charge it, but of course you can charge it anyway. Full electric, it is required. AC or DC charging is required, okay? And these are the connectors. Again, for plug-in hybrid and extended range hybrid, it is not mandatory to charge your car, but still it is optional, so you can charge your car with AC, okay? All right, so as an end user, you need to know which kind of electric vehicle charger you need, okay? But for doing it, you need to know the technical specs of your electric vehicle. So let's see some examples together. So there are a lot of full electric vehicles in the list, but I want to draw your attention to the charging support area. As you can see, every car brand and every model can have different maximum charging supports. So let's look at Renault Zoe. It accepts 22 kilowatt AC which is the maximum charging acceptance in the market for AC actually. But for DC, it takes maximum 50 kilowatts. When you see Porsche Taycan, it accepts less AC power compared to Renault Zoe, but it can get very, very high DC power up to 270 kilowatts. So let's do one charging time estimation example together, okay? This is Jaguar I-Pace, and these are its specs. We have usable capacity of the battery, 90 kilowatt hour. We have AC charge power support up to 7.4 kilowatt AC, and for DC, we have support up to 100 kilowatts. Okay, so if you want to know, let's say we want to know how many hours we need for charging. Okay, this is my question for you. I want you to estimate a time for me. Let me share the question with you. All right, I launched. So I want you to tell me, it's estimated, of course, we cannot find the super 100% charging time. So just try to estimate how many hours we need from 0% to 100% with 11 kilowatt AC. It is a tricky question again. All right. Oh. Okay. Interesting. All right. Yeah, still answers are coming. Interesting. Okay. Okay, so let me share the answers with you. So there are some people still answering. Okay. Okay, let me share the results. Interesting. For 8 hours, maybe what you did, I'm trying to estimate, you took the usable capacity of the battery, 90 kilowatt hour, and you divided by with 11, right? All right, so let's see together. Actually, the equation should be like this. Why? You can say, we have 11 kilowatt AC charger. Why? We are dividing with 7.4. It is because if you try to charge your car with 11 kilowatt AC, your Jaguar I-Pace, as we said before, in the specs, it's written, it accepts maximum 7.4 kilowatt AC. So it doesn't matter if you connect your car to the 22 kilowatt AC wall box, doesn't matter. It will take again 7.4, okay? So if you want to know how many hours do we need for charging, the easiest way is dividing your battery capacity with the charge power, okay? So when we do the math, you see 90 kilowatt hour divided by 7.4 kilowatt is equal to 12.16 hours. It's like 12.10 minutes or something. But due to energy law, there is no chance for the systems can work with 100% efficiency, okay? That is why there should be always a loss. So for example, you can install 11 kilowatt charger to your home, you charge your car, and you realize that you are not getting 11 kilowatts. So you're getting maybe 10 or maybe 10.2 or 10.5. Because of that, just add your result a little bit always, okay? We cannot calculate the exact time, but easily we can calculate an approximate value for every car. So the real time, according to the OEM, is 12 hours, 45 minutes, okay? As we said, we cannot find 100% accurate charging time, but it is very easy to estimate the charging time, okay? All right, so let's see Porsche Taycan together. It's a turbo S-Pack. You see the usable battery and nominal battery. We can use only the usable part of the battery because OEMs, brands are trying to increase their battery's life, okay? If your battery completely finished, and imagine your battery is completely finished and you are stuck at road. Actually, there is still power in the battery, but we cannot use it because of battery health adjustments, okay? All right, so let's see the charging together. We see that it accepts maximum 11 kilowatt for AC and 268 kilowatt for DC. So imagine we have enough power for AC and DC to supply the car. So let's calculate the AC together first. Our usable battery divided by maximum AC charging, can we get 11 kilowatt? It is like kind of equal to 7.5. But for the loss, of course, we need to add it more. And the real charging time, according to OEM, is 9 hours. From 0% to 100%. Yeah, but so let's check the DC also. We are taking again usable battery divided by 216 kilowatts is equal to that. Okay, so you can ask why normally our like Porsche Taycan accepting normally it's written there it's to 268 kilowatt DC, but in the equation we wrote 216 kilowatts as a charging power. Why is that? So let's see together, okay? In this graph, you can see the charging speed versus state of charge of Porsche Taycan, which is our battery percentage, okay? As you can see, when the battery percentage increase after like 50%, you see that charging power with 300 kilowatt charger is decreasing. I'm talking about the yellow line now. It is happening because the car is protecting itself for better battery health, okay? That is why in the equation it is written 216 kilowatts because it is the average of all that yellow cycle, okay? If the car kept getting super fast charging after 80%, as you can see, after 80% is getting super low, then the battery cells burnings, which means loss of cell life could happen, okay? Let's check the blue line for like 150 kilowatt power. You see there is no problem until 80% because compared to the 300 kilowatt charger, it's not fast like this one, okay? So it accepts 150 and after like when you close to the 80%, it is getting lower. Another example from Hyundai Kona. So let's skip to the AC charging directly. Yeah, when you divide your usable capacity of the battery with the charge power, maximum AC charging, it's like 6 hours. You find like 6 hours, but we need to add it more, of course, because of energy loss. You'll see the real charging time according to OEM is 7 hours. Also the same for the DC charging, okay? Please keep in mind that if you see OEMs are giving from 10% to 80% or from 20% to 80% for DC charging. We talked about after 80%, it is not okay to charge our car with DC, okay? If you try to charge your car, yes, you can, but it will decrease the time and it will decrease the power output. All right, so let's see a different example, interesting one. It is a first 3D printed electric vehicle, XEV Yo-Yo. So I want you to calculate the estimated charging time for me, okay? So let me ask the question, chat. Okay, The question is, what is the estimated charging time with 3.6 kilowatt AC, but between 30% to 100%? Okay, I'm getting some answers. So not 0% to 100%, 30% to 100%. So it's like kind of lower, right? It is just an estimation. All right. Okay. So many of you answered. There are still people not answered yet. If you cannot calculate, please don't worry. Just try to estimate one. All right, so let me share the answers to you. I think many of you already answered. Okay. Many of you said less than 4 hours, and it is true. So let me show you. Yeah. Let's see. Our usable capacity battery is 10.3. We are dividing directly. So normally it is from 0% to 100%, right? So we found 3 hours. We need to add more, maybe 4, maybe 4.5. According to the OEM, they says the time less than 4 hours. So you did correct. The other selections were very high. So that is why it is A, the time less than 4 hours is true. And also let's check the DC. But of course we cannot check it because no support, right? We cannot charge our XEV Yo-Yo with DC charging because there is no support. If you want to know about more about other electric vehicle specs, so please check the internet later, okay? There are too many third-party websites on the internet which shows every detail of every electric vehicle. Just type EV database to Google and you will see lots of websites, okay? Right. We learned about the charging power basics for electric vehicles, but also it is better to know how to calculate chargers' powers, right? So for example, we say 11 kilowatt charger, but why it is 11 kilowatt charge? So let's see the power calculations for our chargers. So as we mentioned, if you remember, we have one phase and 3-phase chargers. So let's see our one phase first, 7.4 kilowatt charger together, okay? Our voltage is 230 volts from the grid, of course, and we can provide up to 32 ampere to the car. So we learned power is equal to current times voltage, right? We can do the equation together. You can see P is equal to 32 amperes times 230 volts. It is equal to like 7,360 watts, which is nearly 7.4 kilowatts. Okay, all right, easy. But please don't forget it was a single phase charger. Okay, now let's see the 3-phase charger. So we can get more output, right? So in 3-phase chargers, now we have more voltages due to the 3-phase, and the equation will be slightly different compared to the other one, okay? As you can see, in the equation, we have now extra 1.732 and PF. PF is called power factor, which defined as the ratio of the real power absorbed by the load to the apparent power flowing, okay? We don't want to explain to not confuse you why they are in the equation, but it is better to know when there's it's better to know when there is a three-phase system, we need to add to our equation 1.732 and power factor to the equation, okay? If your charger has a good quality, then your power factor is close to 1, like ours. Like we have 0.69. So there are also other bad, worse quality chargers, maybe 0.94, 0.90, okay? So it is important. For DC, when the equation comes to DC charger, same equation is happening with the last one, but there is an easy way. So we said that DC chargers consist of series connected charging modules, right? For AUTEL, for example, one charging module is 20 kilowatts. So for example, when you open the chassis of your DC charger and imagine you see 6 modules there. So the equation is very easy, actually. 20 kilowatt times 6 is equal to 120 kilowatts, okay? That is very easy. Okay, we know about electric vehicles and chargers, and let's see the advantages and disadvantages of the chargers. Yes, we are talking for AC now. As you can imagine, AC chargers, they are super cheap, maybe 10 times, 20 times more cheaper than DC chargers. They are significantly small. That's why the installation is very simple. It's very cheap and it's very fast. Installation is very faster. And we don't need a very specific, super investing infrastructures. And it provides flexible charging for end users for private AC charging, okay? For example, you can charge your car with nighttime charging, etc. But of course, we have disadvantages. It is, as you see, it is very slow compared to DC. And onboard charging technologies are developing slower. It is true. As you see, if you remember on the equations, we see that only Renault Zoe accepts 22 kilowatt AC chargers, but others are getting still 11 or 7.4 or different, right? And AC charging station can provide up to 22 kilowatts, and not every electric vehicle accepts high power AC charging, as we mentioned before. It is vice versa for DC chargers, and later we will look in detail about it, okay? All right. So we know what kind of charger do we need now according to your electric vehicle, right? As an electric car user, you know that which charger you can get now, but there are also different purposes of installing electric vehicle charger. One is for private using and the other is for public using, okay? Let's look these topics very quickly. All right, so private chargers. Of course, it's for private using. At your home or at your office or any place you own, you can install it and you can charge your electric vehicle. For private charging, AC wall boxes are highly recommended, okay? Because it is very easy to install and very cheap compared to DC chargers. And of course, no need for big electric infrastructure. What we need to pay attention for private chargers, also the charger needs to be safe. It must provide the necessary security standards and it should be equipped with necessary security equipments, okay? The charger, it must be good, it must be of good quality. It is important for users that the device has quality certificates, okay? It is also important for your safety. The charger capability. It is better that the charger should be smart. So actually, there are two types of chargers in the market: smart chargers and dumb chargers. Dumb chargers are simple, just charging your car when it is connected. But this is not recommended and not safe. It can lead blackout due to miscommunication with grid and other home appliances. It can lead some damages or fires on the car. But with smart chargers, users can do many things, like with mobile app, increasing and decreasing the power output in supported gap, or starting and stopping the charging from distance, or like doing a schedule timing. For example, you connect your car to the charger and you can arrange night charging. So you can save money because at night the electricity is cheaper, right? Or also you can check your charging history. And also very important, the charger can communicate with the grid and all other home appliances to arrange proper electrical flow in the whole house. We call that system dynamic load balancing. A flexible and user-friendly environment can be created with smart chargers, okay? So this is very important. Last but not least, the design may be not important for everyone, but if possible for good design, why not, right? Yeah, speaking of design, our Maxi Charger AC and DC won the Red Dot and IF Design Awards for this year, 2022. I wanted to share with you very quickly. Okay, so we have also the public chargers. So mainly these are the fast chargers, and you can charge your battery with paying its money, right? As an investor, and if you want to invest on public chargers, for example, you want to install DC charger and you want to make profit by selling the electricity. Now we have too many factors are involving now, okay? Extra safety measurements like operating temperatures, temperature ratings, environmental safety for all weather conditions, chassis material, communication protocols, upgradable chassis, and many, many more. Also, you need a cloud management system that work as a brain for all chargers outside. With this, controlling the chargers, so with this, you can control the chargers, collect the details, and update the chargers, and more can be done over to air, okay? So the key goal for public charger is to make sure follow all the safety measures as well as longevity of the charger, okay? If it is not safe, the car could catch fire or people can get electrified, okay? If that happens, the charger should be closed. And day by day, you will start losing money. So that is why we want to explain you from scratch how to become a certified power operator or an investor on our next webinar, okay? This topic is very important for everyone who wants to invest on electric vehicle chargers and to choose right chargers. So please follow our social media accounts to get up-to-date information regarding next webinars, okay? If you need any help or suggestions, please feel free to get in touch with nearest AUTEL representative, or you can contact us via email. So let's see our chargers. We have Maxi Charger AC wallbox. We have our Maxi Charger DC wallbox and Maxi Charger DC fast. And we are getting super high power Maxi Charger DC high power. It is up to 480 kilowatts. And for advertisement issues, we can also offer Maxi Charger DC fast with 55-inch advertisement screen. Okay, so I want to say one thing. We are not gathered here to defame our competitors, but it is useful to know that there are bad quality, medium quality, and premium quality chargers in the market. AUTEL Maxi chargers are definitely in the premium charger class with its quality, design, and safety measures. that is the end of our today's webinar. So before entering our questions and answer session, I want to thank you all again for your precious time, and I hope to see you in our next webinars, which we will discuss about business opportunities for electric vehicle charging. And later webinar, we plan to give tips about how to repair and handle the electric vehicles, repair solutions, and safety instructions, okay? So please don't forget to follow AUTEL IMEA social accounts to get up-to-date information, okay? Thank you so much. So let's see the questions, if you have any questions here. Yes, we are getting a lot of, let me answer this. We are getting a lot of records last session and this session. Don't worry, when it is ready, we will publish from our social accounts, okay? Don't worry, guys. Yes, also Mustafa asked the same. Don't worry, we will publish it on our social media, so you can get it direct. Ali Al-Shami, sorry for if I pronounce very wrong. So yes, thank you so much. From Muhammad, there is a question. Country of the origin is China. AUTEL products origin is China. Biju Thomas, thank you so much. Mohammed, you're welcome, of course, always. Pleasure. From Anonymous, for professional work, for more info, the best solution for now is waiting for our next webinar. We will give very detailed information about your question, okay? If you want, yes. There is one question. I want to understand how to charge a hybrid battery in a vehicle. Hybrid battery, if you mean full hybrid vehicle like Toyota hybrids, we are not charging them because it is charging with regenerative braking itself, okay? But if you have plug-in hybrids, then you're just simply charging your car with connecting to one electric vehicle charger. I'm getting a lot of questions about the record, so please don't worry. I know it is not ready. When it is ready, we will publish from social media accounts so you can get it direct, okay? Actually, it's a very good question, Abdurrahman Osama. How much does it cost to build a charging station? So I will not go in detail, but of course, there are many things to do. Just buying the charger is not enough. So on the background, we have a lot of things to do. So please follow the next webinar. We will definitely talk about it. From Mustafa, the next one will be after 1 week. It is not exact yet, so please check our social media accounts to keep updated, okay? It is not exact, but we will remind you via social media accounts. There are too many thank you messages. Thank you so much. It's my pleasure. My pleasure to teach you something at least. From Amir, there's a question. In rainy session, what are the do's and do nots while charging? Okay, actually, nothing to worry about. We will talk about the safety measures also in our next webinars. In rainy session, you can easily charge your car, don't worry, because these connectors have outside protections. If you like you take out the connector and one water drop came to that, don't worry. But yeah, just in case, be careful. They have protection, but while charging, there's no problem. But opening the charger chassis, so yes, that is a problem, and we will talk about it. Okay, there's a good question. It depends. So we can is the AC charging in the car equipped to work 220 volts and 40 volts? If it is a single phase charger, like 7.4 kilowatts AC wall box, okay, it is, because of single phase, it is 220 volts, okay? But if it is a single phase, three phase chargers, like 11 kilowatt or 22 kilowatt, it's working with 100 volts. There are too many thank you questions. You're welcome. It's my pleasure. The next webinar, we will see. It is not exact yet, but it will not be very late. Don't worry. We will keep updated you on our social media accounts. From Amir, how can we recognize AC charger and DC charger in a car? The easiest way, so if you're asking, it is a live car in front of you, the easiest way, you can check the connector diagram. If you open the connector of the car connector, you can see it's AC or DC. But if you're asking, okay, so you want to buy one car, for example, and you don't have it live in front of you, as I said in the webinar, there are too many third-party websites. It shows you is AC charging, DC charging, how many kilowatts, accepting what is the motor's power in horsepower, in kilowatts, everything you can find. So just type EV database to Google, type EV database. You will see very good third-party websites. So also you can compare the cars. You're welcome, everyone. It's my pleasure. It's our pleasure to give you something. All right, there is one question and my colleague is answering. All right, I think there is one question. Who can repair a bad charger and what is the allowable temperature does it work? So it depends actually. So normally the manufacturer repair the bad charger, okay? If there is a problem on the charger, manufacturer will repair it. But if it is a minor thing, then also a dealer or distributor can handle this also. What is the allowable temperature? Okay, it depends actually. Ours are very great. It is between -30, it should be -30 to +55 environmental temperature, and operating temperature, of course, the working temperature is very more. We are because we are in the premium class, that's why our allowable temperature should be okay. But also there are some temperatures starts from -20 to 50 or something like that. But we are going -30 to 55. All right, you're welcome. It's my pleasure. There are many thank you questions. There is one more question. Where can I get the EV full diagram for repairing? So to be honest, for every car brand, every module also, not only the brand, also the models itself, they can be different. So when you check for Suzuki, for example, the plug-in hybrids, it's different. When you go for the European ones, it's different. So full diagrams are not easy to collect because it is like confidential OEMs informations. It is not easy, but the easiest way you find, if you can, is the internet. But for the tips, repair tips, please follow our media. So AUTEL IMEA social accounts for the next webinars, okay? We will definitely give you something. There's one thing I don't understand the battery graph. Okay, let me explain a little bit for you, Ferry. Think the graph or not think the graph. The car says, okay, you are charging the car with very, very high power output, okay? You can imagine like you are trying to charge your laptop battery. The laptop says, okay, for like up to 50%, something like that, it says, okay, but after it is dangerous for me. It says it is dangerous for me, and it starts to limit the charging rate, okay? Because the fast charging can lead the cells burning, okay, at the end. So there are many, many cells in the battery packs. So you are actually charging these cells, okay? So we have battery. Inside, we have battery modules. For example, you have 6 modules or 8 modules. And in every modules, we have maybe 8, maybe 10 battery cells. So we are actually charging these cells, and these cells should be charged equally. But it is not an easy thing, okay? There are some times you cannot charge these cells equally. And if you try to charge, for example, you can say like after like 80%, there will be some cells maybe like 100%, but there will be some cells like maybe 50%, but still you are trying to charge this 100% cell, okay? Think like that. So this cell can lose its life. That is why the graph, which I showed you, it's going down. So the car accepts less charging power, okay? For the slow charging, it's no problem because it is easy to operate it. But for very, very high powers, the car should be careful, okay? For the recorded session, as I said before, don't worry. We will share it via our AUTEL IMEA social accounts. All right, I think that is it, right? Okay. I thank you again for your precious time, and I hope you see you again in our next webinars. So please follow our social media accounts to get updated webinar information, okay? I hope to see you guys again, and have a nice weekend. Goodbye.